Next, linker sections, up. Sections and relocation, contents index. Separator, 4.1 background. Roughly, a section is a range of addresses, with no gaps. All data in those addresses is treated the same for some particular purpose. For example, there may be a read-only section. The linker LD reads many object files, partial programs, and combines their contents to form a runnable program. When it emits an object file, the partial program is assumed to start at address 0 LD, assigns the final addresses for the partial program, so that different partial programs do not overlap. This is actually an oversimplification, but it suffices to explain how its use is sections. LD moves blocks of bytes of your program to their runtime addresses. These blocks slide to their runtime addresses as rigid units. Their length does not change, and neither does the order of bytes within them. Such a rigid unit is called a section. Assigning runtime addresses to sections is called relocation. It includes the task of adjusting mentions of object file addresses so they refer to the proper runtime addresses. For the H8/300 and for the Renesys Super SH, as pad sections if needed to ensure they end on a word. 16-bit boundary. An object file written by AS has at least 3 sections, any of which may be empty. These are named text, data, and BSS sections. When it generates COF or ELF output, AS can also generate whatever other named sections you specify using the dot section directive, C dot section. If you do not use any directives that place output in the dot text or dot data sections, these sections still exist, but are empty. When it generates SOM or ELF output for the HPPA, AS can also generate whatever other named sections you specify using the dot space and dot subspace directives. CHP 9000 Series 800 Assembly Language Reference Manual, HP 92432-90001 for details on the dot space and dot subspace assembler directives. Additionally, AS uses different names for the standard text, data, and BSS sections when generating SOM output. Program text is placed into the $code $section, data into $data, and BSS into $BSS. Within the object file, the text section starts at address 0, the data section follows, and the BSS section follows the data section. When generating either SOM or ELF output files on the HPPA, the text section starts at address 0, the data section at address 0 by 4 million, and the BSS section follows the data section. To let LD know which data changes when the sections are relocated, and how to change that data, AS also writes to the object file details of the relocation needed. To perform relocation, LD must know each time an address in the object file is mentioned. Where in the object file is the beginning of this reference to an address? How long in bytes is this reference? Which section does the address refer to? What is the numeric value of address? Start address of section. Is the reference to an address program counter relative? In fact, every address as ever uses is expressed as section plus offset into section. Further, most expressions as computes have this section relative nature. For some object formats, such as SOM for the HPPA, some expressions are symbol relative instead. In this manual, we use the notation secname n to mean offset n into section secname. Apart from text, data, and BSS sections, you need to know about the absolute section. When LD mixes partial programs, addresses in the absolute section remain unchanged. For example, address absolute 0 is relocated to runtime address 0 by LD. Although the linker never arranges two partial programs' data sections with overlapping addresses, after linking, by definition, their absolute sections must overlap. Address absolute to 39 in one part of a program is always the same address when the program is running as address absolute to 39 in any other part of the program. The idea of sections is extended to the undefined section. Any address whose section is unknown at assembly time is by definition rendered undefined U where U is filled in later. Since numbers are always defined, the only way to generate an undefined address is to mention an undefined symbol. A reference to a named common block would be such a symbol. Its value is unknown at assembly time, so it has section undefined. By analogy, the word section is used to describe groups of sections in the link program. LD puts all partial programs, text sections, and contiguous addresses in the link program. It is customary to refer to the text section of a program, meaning all the addresses of all partial programs' text sections. Likewise for data and BSS sections. So sections are manipulated by LD, others are invented for use of as and have no meaning except during assembly. Separator. Next, linker sections, up. Sections and relocation, contents index.